Welcome to Model and Detailing Management Module. Part 1, 3D Modeling and 2D Detailing. In this video, I will show the path that varying members take within the module, from basic entry in the model through approval. We will begin by selecting some member and adding the finish to them. Within the Update System window, I have a column for finishing. I can select either the current default paint or finish for the project, or perhaps something other than the normal. So in this case, if this member was galvanized, I could select galvanized. At this point, the modeler would stick the member. Setting a member to stick indicates that the user has entered the member in the model in accordance to the engineer drawings. This would include section size, its placement, its grade, etc. At any time, if required, I can place a member on hold. Now, there are some pre-selectable reasons, or the user can enter their own. Once members are sticked, they can begin their pre-check. This allows the checker in 3D to check varying items, from web rotation all the way to steel grade. This would ensure future problems would not exist due to these items already having been checked. Once pre-check is done, the members can have their ABMs run, and the members can continue with the adding of connections as well as any manually modeling required. The next step would be for the 3D modeler to add the connections to the left and right end and verify that they are in accordance with project specifications. Doing so will change their color as they appear in the model, indicating that the left and right ends have been done. The next would be to release the member for checking in 3D. Now there's two ways to check the material in 3D. There's the automatic way. Now in the case of these B5s, they are infill beams, quite easy to check. So the 3D checker has verified everything is correct. We will now do a manual material check on the last 12 by 22. I can select individual pieces of material for that member and release them as they're checked. In the case of the connections, I have 4 pieces of this same angle connection on the member. I can update them all at once. However, when we come to the stiffener, the checker has indicated or found that the thickness is incorrect. So we will error it out, decide who to send it to, and the reason for the error. Once done, the 3D modeler, if he runs or she runs any tool found within the module, a warning or an indication will open, indicating something for them to fix. From this window, they can open the model check window and find out the error. So the 3D modeler would verify the incorrect thickness and, of course, adjust it. Once done, they will rerun the tool and send the item for back checking back to the 3D checker. And once again, if the 3D checker runs any of the tools, it will indicate something to check. Once done, they can recheck it and verify the item or items are correct. So now those members in yellow have been checked in 3D and they are ready for the next step. Which is to release for detailing. So they are ready for the 2D portion. And of course, there are 2 ways to detail a member. We can automatically detail it, and of course insert them upon their sheets using detail sheet auto loading. If the user wishes, they can also manually detail a member. using the Update System tool. As it's set up currently, when I detail it manually, there is an option for a new piece mark. This is indicated of a piece mark library that's being used in the system. So the system has given me an available piece mark, and I will actually use that piece mark when renaming this beam. So the 2D detailer has detailed the beam, and they've added annotations in the case of an extra dimension and a notation for paint. You will notice that the color is different. The reason for this are twofold. One, that in SDS2, I can see exactly what the user added manually. And the second reason will become apparent in a moment when we begin checking in 2D. So the last thing left to do is to insert the detail upon a sheet, and of course, rename it, in accordance to the library detail that we've already created. Now what the detailer would do is, in the model, they would let the checker know that these items are ready to be checked in 2D. So the first thing it would do is create an exact copy of the detail in PDF format. So these members are now ready to check. At this point, the 2D checker would run the drawing control tool and realize that there are members ready for checking. They would transfer to the checking column and, of course, open said drawings, verifying the information is correct. And in the case of the ones that are in brown, those are dimensions or items the user has added, and they will check them or verify them as noted. In the case of items that are not in yellow, these are just checked to make sure that they can be fabricated. The information has already been checked in the model. So now that they've been checked, one item is finished, so we will transfer it to the final check column, which means they're ready for the next step. However, there is one that needs to be fixed. Now the 2D detailer would run the drawing control tool and notice that there is something for back checking. They would open the PDF and see the information that the checker has left, and of course verify that this is true, and if it is, to fix the 2D detail in SDS2 accordingly. And of course, note that the 2D PDF has been fixed. And transfer the item to the recheck column. Now again, the checker would come in and see that there's an item for rechecking. They select the open button, and a copy is created right away of the new detail. And we have a history of this detail. So there's an archive automatically created. And once done, we can move it to the final check column. So these beams have been finished and are ready for the next step. Part 2, transmittal, return from approval, and revision. At this point, we will create a transmittal for approval. Now the drawing log will indicate all current details that are ready for transmittal. We can also select the type of transmittal. I will create a transmittal number. I can set who I'm sending it to and who from. I can select the language as well as the date, or I can use today's date. Now I will create the transmittal, and I will update the information. So within the drawing list column, I have erection drawings, submaterial drawings, and detail drawings that I can send for submittal. I will just select my detail drawings. By selecting them, I can show them in model. I can also load a pre-selected list. I can auto-load, say, gather sheets that belong to those details. So I will add them to the selected transmittal and continue with the finalization. So I will begin by incrementing the sheet revisions. Now, of course, as I created that transmittal, it created several selection lists. So in this case, I am going to use the detail. So I'm updating my revision table within the individual drawings. At this point, the user can decide which items are to be shipped with the transmittal. I can include an Excel file of all the items in my transmittal, including the details and their sheet size, as well as the current revision. I can also compare the 3D model to the 2D bill of material to make sure everything matches. I can also select the plot to file my detail sheets. Now, of course, they will include any revision in the revision chart that I've created. I can select CNC, and then within my Setup tab, I can select which CNC's configurations are to be used, including KISS files, any shop or field bolt reports, as well as zipping the job. Or I can do it in one shot using the package. Just check the items and select Go. Once my options and choices have been made, I just select Finalize Transmittal. And now I have a folder that I can send for transmittal to the appropriate recipients. At this point, I would receive my approval information and must apply it to the transmittal TA001. So I can run the drawing log, and of course, under the approval return, I can select the transmittal I wish to set. And of course, I have a column indicating anything that's not reviewed. I can select them all and put them into the approved list. But in my case, I have a few members that have not been approved. So I will transfer the ones that are approved to the approval list, and the remaining 3 will go into the revise and resubmit column. Now, of course, I can select them and find them in the model by selecting Show in Model. I will now create and attach a new addendum called UX001. So under the Attachment tool, Addendum, I will create a new one called UX001. Having created it, I will attach it to the selected members in the model. I can also create a status display for this revision on the fly. At this point, I would run the Update System tool and select the Revision Update tab. I will highlight the current revision. And then add in a pre-selected option of what is being done. In this case, the beam is being relocated up 6 inches. I will type in the change that I'm doing. And on the columns, of course, the holes are going to move in accordance to the beam's different elevation. I will then continue with removing certain items on these beams. Because they are no longer finished, I must start not from the beginning, but at least until the point, in the case of these members, to when the connections were done on the left and right. So at this point, having added my revision, I would make my changes in the model. Select Revised Material, and release it for checking. And then we would continue the steps from part 1. Just going through the different steps for releasing the detail, redetail them, and of course, checking the detail and finalizing them.